what's happening here? Is this going to work? Yes. Okay. So there's a thread through what I'm trying to do now, trying to talk about now, which is form. And hopefully by the end of this, you'll have a better appreciation of what I intend form, what I'm using the word form to mean, and how it fits into the overall story that I'm trying to tell. I'm going to go through a series of steps, which is a form. There's going to be quite a few form jokes here. We're going to start off with where BORO is at the moment. I'm framing this as in a sense, as a personal or a BORO personal, sort of from a BORO perspective, rather than trying to say a general perspective, because I don't want to make a claim that you're all going to share the perspectives. So this is really a story about a problem that we have, that if it resonates with you, you can maybe follow along the same journey. Maybe it doesn't resonate, so you're going to go a different way. We sort of talk about framing, which is framing the challenge. We focus on innovation. I think that's a nice way of looking at it. And then I add form in towards the end, making it much, much clearer how form fits into the story. So from a BORO perspective, we're a research-based organization, and we're sort of with a very special focus, and we're saying really, what should we be doing, where should we go? And I think the first thing that you need when you ask these questions is you need to say, where are we now? And there are multiple ways to characterize it. And I'm going to do that in this section. And then the further sections, when we've clarified that, I'm going to move on to how do we work out which way to go forward. So if you've been following us at all, you'll have seen us present what we do in various ways. We often present it as two frameworks, a top ontology framework and a Be Clearer process for enabling you to get to the top ontology. You can see the same sort of thing here, but the focus is different. We're saying, look, we can build you a foundational ontology, something built on top ontology, which you can then reuse. We can also say, look, you can exploit it in various ways, and which is true, and we've done it in lots of different ways. This is a general tool for doing all sorts of things, which I think is slightly different from, if you like, the RDFL type ontologies, which have a particular focus. But within this is one particular process that we talk about transformations, which is actually, I think there's more of our works in transformation than in the other. Well, I don't even know whether that's true. But when we look carefully at it, is that within all of these things, within all of the various different forms of exploitation, there is this notion of information transformation or information transmission. So where we get one system coming in, this is a picture of Be Clearer, and it's been slightly tidied up to look a bit like data migration. So you have your source system coming in, you clean up all the data on it, and then you load it into a target system, which has got a different schema structure. So effectively, you're merging the schemas from your new system with the data from your old system. So you've got an integration exercise that you're going through. And this is something like this, if you like, characterized in every piece of work we do, there is always something like this going on. And what always crops up is interoperability as a major barrier. And in some cases, it's more like the cost of interoperability. So if we had, enough time and enough money and enough people, any bit of interoperability could be fixed. But just in the scope of the project, it just doesn't make sense to fix it. We need to be clear about how we think about interoperability and cost. And there's Ronald Coase talked to the nature of the firm. He got this idea that the cost of the transaction is such that inside the firm, it's cheaper to manage it yourself than incur the cost you get in the mark of the transaction. And it's a similar thing going on here. And I'm not the first person to do this. They've talked a lot about when they're trying to compare monoliths with smaller componentized systems. They've looked at a Coasean cost of information transaction to try and work out what's going on. And I think something like this is underlying any story you have about interoperability. But moving on, I think we want to be able to have think about this, what's going on. And I've generalized here the notion of Be Clearer to data migration. And I'm saying we've got this we've got this pattern of a schematic pattern of transmission. In this case, what's happening is we're trying to migrate two systems into a new system. So we start off by migrating them both into the new system and then aligning the data. So we've got a series of information transmissions that go on. I mean, if we take it even further, we can have this, we can see there's a series of information transmissions. And if you look at if you go to enterprise and you look at your application portfolio, particularly over time, is you do see some systems stick around forever, but the majority of systems getting replaced. So you have a series of generations of systems. So you get what this schematic captures is you get this data in one system is transmitted to another system, is transmitted to another system. And if you look at this from a biological point of view, it's a little bit like a Weizmannian picture of where he talks about the germline and the soma, where the germline's preserved, so our genes are preserved, the somas, our bodies aren't. And there's something similar going on here, where the data is preserved as it goes through generations. And one of the things, a typical Weizmannian claim is that data is potentially immortal. It's data that survives through all of these migrations where the systems don't. It's not quite the same. Weizmann was also doing this to try and show that Lamarckism doesn't work. So there are other stories going on here, but superficially you can see a Weizmannian story. And also I think that if you stand back far enough, there is a question of, have you set up over, so if you're looking at decades rather than years or months, have you set up a way of transmitting the data so it's preserved down through the generations? So there are multiple ways to look at our situation. We've focused on this information transmission as with interoperability within it as being the thing that where we want to start from, the focus of what we want to do. So the next question is that what's a sensible way forward? Is there a clear way forward? If not, how do we find it? We think it's not obvious which way to go. We're not confident. I think there are other people who say, oh, you just need to build your top ontologies. We've been doing it for a while. It doesn't seem to be there are all sorts of benefits, but it definitely isn't the way in which the world is going to change. And so we now we go to the meta question is, what if we're trying to find a way forward, what method should we use for going forward? Now there's a framing appears in a number of different places, a number of different ways. There's quite a lot of literature, even though the dates here, they've got dates. If you look at the bottom of 17 and 90, I think most of it was actually in the 90s, of the idea that you need to frame your problem rather than focus on improving the efficiency of the particular problem solving processes that you have. And this can be seen a rehash of Kuhn in some ways, is that, if you like, a reflection of people who've been exposed to Kuhn's work and looking at what they're doing. And particularly the thing that I'm looking at most recently is this house book Fruitfulness is really, really useful if you're trying to get an understanding of what's going on. And if you see, if you like, the history of science as being, in a sense, a history of information management. So within this framing thing, the idea is that you need to realize that framing isn't problem solving. They're two different kinds of things. That the framing can have a much bigger impact on whether you're successful or not than the problem solving. So if you have a series of problem solving things, if you focus on trying to improve their efficiency, you're not going to get the big improvements, particularly the radical improvements. You need to go back and check your framing. And the other thing is leverage points, is that you need to work out, first of all, finding the right frame, which is a leverage, but within the frame that you have, which points are where you can do a small amount of work and get a significant benefit. Just to, if you like, re-emphasize what's going on in framing here is the Kuhn used this idea of a Gestalt image. He uses duck rabbit. I have this from my book, which is it's the Ruben vase example. There's only one image, but there are two ways of doing it. And if you look on the right-hand side, you look at the two, I don't know, conceptual models of what's going on. They're radically different. So you can start for the same physical data and view it in radically different ways. The thing that's interesting about this is that, and it comes up again and again, is that finding the radical reframing is difficult. When Kuhn was doing his history, some of the reasons is people had to be in the right situation, have the right motivations for doing it, but it was also difficult. I came across this, it was actually from the half book, and this is biased because it's a friend of Newton writing it down, but this is a contemporary of Newton talking about what happened when Marquis de l'Hôpital saw a section in the Principia that he related to. He says he cried out with admiration, "Good God, what a fund of knowledge there is in that book." So he was really surprised, and the surprise is twofold. It's one is that it's not something he thought about. It was difficult to find, but also it was not a, it was a solution that was not what he expected at all. So I think we've got this problem of that. Part of what we want to do with framing is to find these solutions where someone else hopefully will cry out with admiration. Okay, so just some examples. Hacking has this, I've got it as well, so it's quite a common example, is that if it's trying to work out what's happened. So if you're a chemist in the end of the 19th century and you were thinking about chlorine, you think about its atomic weight, because you had this idea of all elements being sort of the basic atom, indivisible, and they'd have a weight, and you'd express the weight as a ratio of the weight of hydrogen, in this case 35.453, and felt you'd made a major contribution to science. Fast forward to the 1920s, and you now realize that you've got a different view of atoms, they're composed of different things, and you've got isotopes, so you can have two different isotopes. And in fact, the atomic weight is not an attribute of the atom at all. It's a ratio, but it's a ratio of isotopes you have, and in different situations you can have different ratios. So what becomes important is identifying the isotopes. There's a shift. So you have this reframing that's going on. What's interesting as well is this leverage point, is that where would you find it? How was it found? It was actually found by research into radioactivity. They had various different radioactive breakdowns that were going on, and the same element came back but with a different weight. And Frederick Soddy was looking at this, he found it out. And so incidentally, somewhere else, not looking at the particular what was going on, came up with this the realization that there were isotopes. There is for the people who follow framing in the business world, business management type world, you like something that involves enterprises and money. The standard example is the Panama Canal. The French built the Suez Canal, thought we're good at building canals, went to try and build the Panama Canal, and they basically got nowhere, and they lost enormous numbers of people. 22,000, there's an estimated 22,000 people died. The Americans, they kept the project slightly open and sold it on to the Americans. Americans started doing it. Americans succeeded. Now you'd say, okay, better engineering, but it turns out that what it was is they had to reframe the problem in terms of hygiene and disease management rather than building the canal. And so once they recognized the role of mosquitoes as a disease vector, one of the things they did is they cleared the jungle around the works. There was a 100-yard gap of no jungle before all the canal works, so the mosquitoes didn't get there. Significantly less death, and they finished the canal. Of course, not the only thing. They used locks and so forth, but they had to do this reframing exercise. So look at it in a different way. Success depended on looking in a different way. So we're trying to frame or describe, if you like, the way that we're going about it, our approach in terms of a reframing. Finding the new frame can be challenging. It can be challenging for us as pathfinders when you find the frame, and it can be challenging for, if you like, the people trying to follow behind us to go along the same journey, because they have to, if you like, shift their perspective on things. There's also this issue about finding the leverage points. Where can you move fastest, and which places can you take advantage of the new way of thinking about things? So the thing that we're going to come up with is if you like, if we go 2 levels of meta, is the methodology for framing is going to be something called genealogy. Within philosophy, that's associated with Nietzsche, and then with Foucault calls it archaeology. I was particularly impressed. There's a woman, Katerina Duluth-Narvaez, that in a conceptual genealogy for analytic philosophy also talks about form and how the form works, and she has a 2012 book on form, so she uses the same process. So this is a commonplace process. So what you do is you start with the topic, and the way in which you try and get a wider frame is you look at its history. You try to see what's going on. So that's what we're going to try and do here. So again, if we take if you like, information as a general topic, and we look at the forms, the standard forms would be physical media, and there's a standard breakdown would go speech, text, and digital. So you have these 3 disruptions that are going on in terms of if just looking at information in terms of humans or Homo sapiens, yeah. And one of the things that we note is that it is the case that historically, if you look about it, we talk about the discovery of language and the discovery of writing as being, major changes in disruptive changes, disruptive events in the history of the human race. We're trying to if you like, in order to make it easy to think about these things, we're proposing that there's a way of breaking it down, a way of classifying things. Peter, I think your microphone might be on. So your is it? Yeah. Okay. So this is giving us some kind of framework to see things. I mean, you might well have a different framework. There are lots and lots of different frameworks, all with their benefits. We're not claiming that this is the only one, just useful for what we want to do. So if we now try and map it out in a certain way. So here you're trying to see this is of what's going on broken down. One of the things that comes out of this is that originally the if you like the ecosystem, the information ecosystem is brain, maybe brain and speech, sort of communicating. And now what we've got as a result of the latest, we've now got an ecosystem because it's got all the components of the ecosystem. It's got storage, it's got processing, communication. Again, if you trying to look at a different way, trying to say what's different, I think what's emerged is this communication of external to external, which is computers to computers and processing, the computers to processing. This bit here is after the digital revolution. This is what's new, and you could say that look, if there are these, and it was true historically, for instance, with text and speech, one of the ways in which you can think about where you might want to find, where you might look for innovations to exploit, it's where there's been a change. So it would be in this case where the disruptions are. Just a slight sidetrack here is that there are other human information revolutions that weren't formal. So the printing is a major one, paper a less minor one, again from a Western European point of view. And these had a disruptive impact, but the disruptive was economic rather than form. And the reason they're interesting, well, there's a couple of, well, one of the major reasons they're interesting is that we have more information about them because they're more recent, and also we actually have, they're historic because we have text on them. And one of the things that it shows is that that's particularly clear is that it's not the technology. The technology is not enough by itself to generate a disruption, because that the particular thing is movable type technology. It was invented around the millennium in China. It didn't have the disruptive effect it had in Europe. So the story is that there's a co-evolution of cultural practice and technology by itself is insufficient to generate the disruption. One of the questions, this is in a sense looking ahead to 3 or 4 sections further on, but if I just mark it now, is that we agree that there are these, or hopefully it's reasonably clear that from a form perspective, it looks as though there are these 3 kinds of technological revolutions that have happened. I think the issue is, have we actually had the digital revolution? So given this story about China and printing, are we like China at the millennium where we've discovered the technology but not the right way of using it to be able to exploit the opportunities? And I think that's going to be what I'm going to claim. So I'm just, if you like, seeding that thought in you for later on when we sort of approach it more directly. So just to recap the section, we took a genealogical approach. We can fit, if you like, our current situation, this digital thing, we've got information transmission and be clear, or data migration, into a whole series of history of evolutions, previous evolutions of speech and text. We can see that there is a structural novelty that's occurring with the digital revolution, where you've got a digital ecosystem, you have a new ecosystem, where you have a machine-to-machine communication and intra-machine processing. And the last point was the thing I thought ahead, is the emergence of digital technology by itself constitute a revolution? It may be necessary, but is it sufficient? Following on the genealogy and the framing process, we looked at human information evolution. The term evolution was used probably as an analogy with biological evolution, if you like. They were trying to say there were similar patterns rather than trying to make a stronger point, which is what we're going to do in this section. What we're going to suggest is that if you take this strong information perspective, and the notion of information is pervading all sorts of places, as you know, biology as well as physics, and we can say to do that, you can actually shift from seeing human information evolution as evolution by analogy to see it as part of a larger information evolution stretch, which we're doing here. I think the first thing that we want to do is just say that this what we're doing here, that the moving as far as saying it's this if you like, it's a part of it, is probably not as common, but just doing the comparison, saying they're the same is very, very common. And you can certainly interpret a lot of the talk about the similarities between the two as saying, look, it's basically the same kind of thing. I think some people resist this, particularly they say, well, no, what's going on in information evolution, what's going on in fact in digital information isn't really a biological evolution at all. Just this point here, there's this one paper. I've just taken this one paper. It's easy. Here's the text from the paper. Here's the references. This is just some indication of the amount of literature there is about the topic. So it's a well discussed, well posited theme, that this relation between information and biological evolution, and also particularly digital information innovation and biological evolution. If you go back to biology and you're trying to work out how to position it, there's a discipline within biology called macroevolutionary biology, which I think is the place to look. And within it, there's work that Maynard Smith and his colleague has been doing, where they've made this claim that actually evolution is all about information transition, if you look at what's going on. And there's a quote there: major transitions in evolution typically involve transitions to new kinds of ways in which information is stored and transmitted, understood as transitions to new kinds of replicating entities. And in a sense, if you've been listening a little, these replicating entities look a little bit like our data information transmission. And the other one of the key phrases they use is evolution evolves. It's not just evolution, and it evolves with the emergence of new forms of information storage and transmission, which again resonates with our story about human information evolution. Here, Maynard Smith came up with 8 things here, and there's some argument about what the 8 are and so forth, but at least it gives you a feel for what's going on. And I think you can begin to see how, if you like, our story about human information evolution could be added to the end of this. So he stops at language. We could add in printing and digital at the end of this relatively easily. If we look at one pattern of information transmission, which is the thing that we started at the beginning, is that it's very akin to a pattern that Dawkins raised of what he called replicators in vehicles. So there's, if you like, there is something that's given the job of replicating, and there's some have given the job of the vehicle doing whatever it needs to be done. And we get the same thing in the system. We see the system here is that this is an exact copy of this schema that we had before. So this could be seen as, if you like, as genetic. In this case, it'll be something like sexual reproduction, because there's 2 inputs at the start. The thing to note is that central to this way of talking, in fact, central to all notions of evolution, is the fidelity of replication. And you can see that fidelity can be seen as interoperability, and poor fidelity, and there are histories, if you go back to history evolution, there are examples of where poor fidelity leads down to a breakdown of a hereditary. There's something that for RNA-based reproduction, where they have something called an error catastrophe. When error mutations get in to the line, that the whole thing breaks down, and it's the end of the that particular germ line. Okay, so just this is reiterating here is that inheritance is about fidelity of transmission. So if you're going to pass something reliably down from one generation to the next, it needs to be done faithfully. You can do an experiment, assume there's no fidelity at all. There's no in the transmission, and there's no inheritance. So there is obviously a link between fidelity and a level of fidelity and successful inheritance. Okay. The other thing that I think is coming out, we would like to claim, and this is like an intuitive judgment, is that if you look at digital interoperability, so you look at digital heritability, it does seem to have an element of, it seems to lack sufficient fidelity for, if you like, for large-scale use. The transmission, if you like, the replication process seems to be insufficiently efficient for the kind of purposes that we'd like to use it for. Or if we could make it more efficient, we could significantly improve the way in which the digital ecosystems work. I think we've covered that. Could someone give me 10:30? Okay. So I've got till, I think, 10 to 11 is something like that. Is that
well,
right?
if you yes, Chris, you're fine at the moment. If you could stop a bit before that to take any questions. Interestingly, there's nothing in the chat yet, which is unusual for this group. So maybe everyone just agrees with you. But anyway, you've got plenty of time.
I was going to say that's the positive interpretation. Okay, cool. So this is so we go back a sec. So in a sense, just trying to give you a feel, and I'm retreating now, if you like, to the digital world, a feeling for why the need for interoperability emerges. And there's some nice pictures that came up. This is a picture from, if you actually look at it, I was going to say the 90s. It started in the 1980s. There are various versions. I think this is a version from the 90s, as you can tell, because the islands only go up to the 90s. I like the what's the word, the rhetoric. After the ice period some 10,000 years ago, the land is still rising and exposing new terrain never before stepped on by man in a suitable parchment document. I think this is a nice way of visualizing what's happening. I think that if the way in which I build on this, and well, in fact, you can see there are, you can see some bridges appearing here, is if you look at it over time, is if you've got these, at the early days, you've got these isolated systems that are, not connected at all, there wouldn't be any reason to make a bridge between them. As the systems go bigger, more and more of the enterprise is automated. The systems abut one another, and it seems a bit silly to print out from one system and rekey in exactly the same information in the new system. So you start building the bridges, and as the more of the enterprise gets automated, more of these opportunities for exchanging data come in. And I think that also the size, so the islands become continents, maybe, if you're going to follow through on the metaphor. I mean, one of the things that I think is apparent when you start thinking about it is that the bridges are pretty narrow in terms of the amount of data. So if you've done one API for a system and you want to try and do new data, you've got to build a new API. So the original bridge is often not big enough for what's going on. And the other point that I think is just worth thinking about is the way in which the bridges are not interconnected. So if you think of them as roads, is that just because you can interchange information between system A and B, and you also have an API between systems B and C, it doesn't mean the information that goes from A to B can then go on to C. So that they're not always onward connected. In the picture on the side, that's what this thing is meant to do. If you take a more complex picture, you can see that the transmission is both horizontal and vertical. This is a little bit of a simplification. Well, maybe it's a gross simplification in some levels, but you have systems where you have data migration where one system gets replaced by another, which you have time going up and down the page, which is common in these biological pictures of it, is that you have something that, and you go, right, you have vertical transmission, and then you have APIs, which are horizontal transmission. So you can get a picture of if you look at the communication aspect, if you remember, we broke it down to storage, processing, communication. From a communication perspective, you get vertical and horizontal communication. Okay, again, this thing that keeps on coming back is the transmission is not really as efficient as it should be. Quickly to go into the population is that we've done it's the amount of information is important. So we've done a breakdown here between analog and digital. Digital is any digital. Within digital, we've got digitized, meaning that it is digital, but the content hasn't been made digitalized when it has. So if you look at the engineering drawing on the right, if it was paper, it would be analog. If it was scanned, it would be digitized. And if it was a native format, it would be digitalized, because then it's only at the digitalized level that the engineering drawings software can work on it. And in a sense, it can participate fully in the digital ecosystem. Again, we're doing our standard sort of breakdown. Digital goes to digitized and digitalized. And then if you look at the literature about information, where it comes from, it's whether it's analog born or digital born, is quite something that you want to track. If we then sort of look it up, we then get various pathways. So analog can become digital, digitized, so scanned data can become digitalized. There are ways of OCRing, for example, and stuff like that. So there are pathways of changing it. But I think most of the, if we then translate this into, okay, so let's go back. So if we translate this in, I think most of the stuff is actually new. So it's digital born and it's digitalized born and so forth. Just to point out that there is in terms of the history of the different revolutions, there is something similar to what I believe is going on now. There's a period of from 1450 to 1501 where the books were known as the incunabuli, because they were still, if you like, half manuscript books, not quite printed books. Even though they were printed, they got all the features of printed books. So there is a recurring pattern going on here. If you can think of with this look of, I will argue that it will be true for digitalized, but certainly digitized is something that's digital, but is not really fully digital. So you've got the same sort of pattern here with the incunabuli. If you go and look at the data, what you see happening is you're seeing these large increases of data, massive increases of data, mostly new data, though there's some migration. And the standard thing is the growth curves are normally increasingly linear. The data, when you look at it, where it's come from, the calculations are very rough, broad based. They're seeing the number of magnetic disks produced and sold and stuff like that. So I think it's more like this is just an impressionistic picture of what's going on. The Wikipedia's got this thing which is saying, if you look at the percentage of analog data to digital just swamping analog in terms of what's going on. Again, this is not just in Wikipedia, elsewhere again and again. You've got the same sort of picture. You could argue that they've got a bias, a reason for promoting this picture, but the underlying facts seem to generally point in this direction. What the details are probably, I don't know whether it'll even ever be really possible to try and work it out with any degree of accuracy. So if you want to look at a picture, as what you have is over time, is that originally there was no digital data at all. In the early days, there wasn't much digital compared with the analog, and the analog keeps on growing. And it's probably true in these cases, which we don't quite realize. In absolute terms, sort of the analog's still growing, because I mean, with printers get better, we print out more stuff. There's all sorts of reasons for printing. And even though there might be a lot more digital data, there's still, if you absolute terms, if you look at what's happening, the analog is probably increasing. But what happens as you get towards the end is that there's so much digital that the analog is a minor, from a volume perspective, largely irrelevant percentage of the information. You can do the same thing if you go from digitized or pre-digitalized to digitalized. So analog and digitized, composed pre-digitalized, you get the same sort of pattern over time of basically you get, because of the cost profile of what's going on, digitalized data, well, and also the requirements of the digital ecosystem, you get masses of digitalized data. Whether or not all pre-digitalized, all analog data is migrated, I think it's a question of cost, and also maybe aesthetics. Maybe people like books, or they want to keep the original documents. So there's going to be a residue that's always around. What this says, and volumes are a really simplistic measure, but if you if you were to redraw this picture so that the size of the objects reflected the volume of information, then nothing, only the bits in that grey, the digital ecosystem in the grey box would be there. All the others would be so small as to be insignificant. I mean, you can raise queries about what happens inside the brain, and maybe that's a different matter. But if you talk about speech, text, or digital, there is way more information going on. I need to move fast. Okay, so let me move fast. So the big question is, has this disruptive evolution happened? And it seems to be. Let's see where we go here. So if you think of value creation and value extraction when you do an innovation, so innovation is value creation is creating innovation, value extraction is losing it. And if you don't keep on value creating in the evolutionary terms, like Alison, is it the Red Queen, is that you basically, the value becomes exhausted, and in a sense your phylum disappears. I mean, at a local enterprise level, you could decide to do exploitation if someone else is doing the creation, but from a global economic perspective, you need to create. And in the business thing, they've started looking at business innovation strategy. They've got something called a blue ocean strategy, and the idea of it's developed by these guys, Kim and Margoyne, is that you should look to create new market spaces or blue oceans rather than looking at the red oceans, so that it's easier to create a new market than to try and fight with existing competitors in the existing market. And they give some sort of framework for how you should do it. You should raise fundamentally different sets of questions. You should not be wedded to industry best practices because they're historical, they're not the future. And you need to, you need to expand and reorient your perspective. And we're claiming we're doing the same kind of things. And then if you go and try and put this onto a technology diffusion picture, speech is there, it's in sort of the laggard section. Text is probably up in the laggard section, it's fully done. If you go for digital, it's probably reasonably well taken up. But if you start looking at digitization or digitalization, then you say there's going to be this new thing coming along, evolve digital, where it is. And if there is a new thing coming along, it's actually at the innovator stage. And that's the stage, if you're after something that's evolved digital, that's where you should be. This is basically trying to say that when this new thing comes along, you'll get the same pattern of this new kind of data is going to take over from the old kind of data, and the old kind of data will disappear. So this is, in a sense, trying to look at the way and where the answer might be. And one of the things that comes up is when you look about form, this is Whitehead here, he says that we can, he says with the aid of symbols, we can make transitions in reasoning almost mechanically by the eye. And he says civilizations advances by extending the number of operations that we can form without thinking about them. So form is the way of doing it. And there was this nice quote at the bottom from here from Jordan when he's talking about a pen and paper, and particularly the calculation that comes up. In a calculation, the pen sometimes seems to be more intelligent than the user. So if we can build digital systems where the form captures the things that we need to do, it can do the work, not us. We're shifting the burden of thinking to the system. Here's an example. A standard example is Roman versus Arabic numerals. I think up until the 16th century, where a lot of people, well, depending on where you look, but people were trying to do things like long division and multiplication. We're using Roman numerals, and it was quite difficult, and you need to be quite advanced. When Arabic numeral comes in, suddenly it's the sort of thing you can teach in, I guess, primary school. There is always been an element of formality. If you look through DNA, can we have some of the features of a formal system? I think what distinguishes digital computers is they are essentially formal. They're at heart formal machines. And so one of the things we need to do is you need to say what form is suitable for the system. Let me do through. So one of the things that we've done is when we're going through our work is that we found naturally certain questions about form arise. And I'd just like to give you some examples. Let's see how I can do going through on time. So the one that you should be familiar with is from the top level ontology architecture, the top level review. If you go through this, you'll see these are graphics from it. There's a lot of talk here about the different formal structures that are needed, which we choose and why. So one of the aspects of implementing a top ontology is trying to implement a form, the right kind of form for dealing with living in the digital ecosystem. Just quickly go through here. We had a project where we were trying to look at graph interoperability with a focus on Neo4j and Stardog. And one of the things we decided to do was to try and look at the mathematical foundations. And when we did, we were surprised to find out how fragmented they were. And these pictures at the bottom give you some idea of the fragmentation. I mean, I talked to some colleagues about it, and they said, oh yes, it is really fragmented, isn't it? And so I think we don't have proper foundations. And one of the things I think, if we're going to start doing digital graphs and work with digital graphs, we need to get the foundations right. And if you look at the standards for graphs, they admit they've got a whole series of different graph forms going on, and they're really trying to find a way of defining a superset, so a graph picture that covers all of the different structures that they've discovered already. And I think if you go back to the foundations, you're actually mapping the graph space and the possibility of what's going on, and there may actually be structures they've not looked at. Here there's something to do with type unification. It's a project we're doing with Oslo University and King's College London with Salvatore Florio and Carlo Nicolai. We have a board which includes Mark and Sergio. I think you're here, aren't you, Sergio, somewhere? I think I saw you. Yeah. And what's going on here, I mean, simplistically, is typically you have systems with a schema, and we're finding ways where you can take the schema. In this case, if you look on the left-hand side, there's a table that's got where lion is the name of the table, it's the name of the schema, is you can put lion inside your domain. So everything goes in the domain. So you actually have a form that is schema neutral, and your schema is in the domain for you to manage it. And certainly in the pipelines, where the Be Clearer pipelines, where we want to look at different ways of organizing different things, having all of the structures, all the information structures in the domain make it a lot easier to work. And you can see similar things actually happening with NoSQL databases. And in fact, if you look at the way RDF works, it's adopted some of the ideas here. And lastly, one of the things that we're working on that we found that trying to keep track of data through transformations in the pipeline has been really difficult. And when we've looked in the literature for people thinking about identity of data through the pipeline, there's been work on provenance and lineage, but it's not looked at the particular topic of ontology identity. It's sort of assumed in it. So one of the things we're working on is building, if you like, a theory, a data ontology, an ontology for data, which focuses on data identity, and we're implementing it to build data identity digital twins. And I think I've hit my time, so I've missed out probably quite a bit. So shall we go to questions?
You have, Chris.
Okay.
Just about hit your time.
Oh,
We want some questions, but I don't see. Am I just not looking? I don't see anything in the chat. Maybe I'm not looking. No.